So in this video, you guys are going to be exploring percent error, which just basically tells you the percentage by which an estimate is off from the original, or it deviates from the original. So there's only a few examples. This is actually a really short video. Please make sure to do the activity at the end. It'll be important for tomorrow's lesson. So percent error is a way for us to determine in percent terms how close an estimate that we made was to the actual amount. So if you just walked out of my test and someone said, well, how do you think you did? And you said, well, I think I got like a 90. That's your estimate. You're estimating that your grade is going to be about a 90. You're estimating that based on the way that you felt walking out of that test. So you're making an educated guess or an estimation about how well you did. When you actually get the test back, you get a 95. So that now you have a concrete, actual example of how well you did. That amount, that 95, is the actual amount. That is what you are going to determine how far your estimate was from. So you're going to figure out the difference between your estimate of 90 and your actual of 95, which gives you 5, and then you're going to create a fraction where the actual amount, that concrete data that you see in front of you, goes on the bottom. So your proportion would be 5 over 95 equals x over 100, and that would give you in percent terms how close your estimate was to your actual amount. Pia estimates that there are 60 M&Ms in a jar. She has no idea how many there really are, but she's looking at the jar. She's going, I think there's about 60. After she counts them, she realizes there are actually 75. So when she gets concrete data, she knows that there are 75 actual M&Ms. The difference between her actual and her estimate are 15. Notice that I'm just finding difference. I'm taking the larger number, whether it's actual or estimate, and I'm subtracting the smaller number, whether it's actual or estimate. I'm finding a positive difference. And then I'm saying, okay, the percent error is what I'm trying to find over 100. I can solve this proportion any way that I choose, whether I want to reduce 15 over 75 by 5 and get 3 over 15 or 1/5, which I know is 20%, or whether I want to cross multiply and get 75x equals 1500, in which case I divide by 75. But anyway I cut it, I get x equals 20%. So that means my percent error was 20%. So in this example, Jane estimates that there are 150 students in the 7th grade. She asked Ms. Chapnick for the actual number of students, and Ms. Chapnick says there were actually 143. So Jane gets concrete data that the number of students in 7th grade is 143. Now she looks back at her estimation, which was 150, and recognizes that there is a 7-student difference between her estimation and the actual amount of students. And then I do x over 100 to find the percent. Again, I could cross multiply. In this case, that's probably easier because bridge method and all the other methods that we have been exploring aren't going to work as well. And when I divide both sides by 143, I get x equal to 4.89, blah, blah, blah. But it says round to the nearest 1/10 of a percent. So I'm going to go ahead and round the 9, use the 9 to round the 8 up to a 9. And so it's going to be 4.9%. So that's a pretty good estimation. She was only about 5% off from the actual amount. So based on Ben's awesome project video, I'm discussing Ben and his dad's amount of giant games. So we're going to use Ben's dad's giant games as an example. Ben estimates that his dad has attended 250 Giants games. When Ben asks his dad says he has been to 236 Giants games. So Ben gets concrete data that his dad has been to exactly 236 Giant games. He then has to say, okay, I said 250, Dad said 236. It means that I was 14 games off. And that's going to equal x over 100. So then when you cross multiply, you get 236x equals 1400. You divide by 236. And you get 5.93, which rounds to about 5.9%. So Ben was approximately 6% off when he estimated how many Giants games his dad had been to. So here's your actual homework assignment. After watching this video, you should have recognized that this topic, percent error, can really be applied to anything. So I want you to look around your house. I want you to talk to your parents or your mom, dad, sister, brother, aunt, uncle, friend. And I want you to think about something that's quantifiable. Something that you could actually, after you give an estimate, count. So I was thinking like number of M&Ms in a bag, number of peanuts in a bag, number of apples in your refrigerator, whatever it is that you could actually end up counting. I want you to think of a topic, and I want you to write that topic on the back of your video worksheet. And after you think of that topic, I want you to estimate how many of that thing you think there are, and I want you to write that estimation down. And then I want you to go and actually count that. So again, it could be the number of Frosted Flakes you're about to pour in your bowl. Okay, it could be the number of ziti that you're going to have for dinner tonight. Whatever it is, I want you to estimate first, and then I want you to be able to, I want it to be something that you're able to count. So you're going to end up, by the end of the evening, having a topic, an estimated amount, and an actual amount. And then based on those estimation and actual amounts, you're going to figure out the percent error. And you're going to bring all this information in tomorrow, and you're going to share it with your group so that everybody can figure out a real-world example where this was actually applied. And then we're going to do one in class tomorrow. So please make sure that you pick a topic, you estimate first, you count second, and then you find percent error third.